This is the AB Calculus Prep session that was given on November 21st, 2015 at Townview High School. I'm going to work a series of 5 problems that we worked out at the session. And these 5 problems had to deal with the concept of P, V, A. And P standing for position, V standing for velocity, and A for acceleration. And these P, V, and A are different relations that are different dimensions of the same thing. Sometimes we'll see these things written as f, the original function, f prime, the first derivative of the original function, and f double prime, the second derivative of the original function. So depending on where you are and what is being asked, we need to respond accordingly. Sometimes we're given velocity, and I think with all these problems in this set, we're given velocity, but then sometimes we're being asked to evaluate right where we are. Sometimes we're asked to evaluate a level below, which is acceleration, and integral calculus goes up a level above. And the relation between these two, to velocity and acceleration, is that velocity sometimes is referred to as v of t, and acceleration is called sometimes a of t, which equals the first derivative, or v prime of t, the first derivative of velocity. So we're going to keep this in mind as we work these problems. And these problems are sanitized to only cover the differential calculus part of the problem and not the integral calculus. The graph of the velocity v of t in feet per second of a car traveling a state road for t between 0 and 50 is shown above. A table of values for v of t in 5-second intervals at time t is shown to the right of the graph. During what intervals of time is the acceleration of the car positive? Give a reason for your answer. Well, what's happening is that when the slope of velocity is positive, that means it is increasing. That means acceleration is positive. So, and that is referred to what I put up earlier. A of t, or acceleration of t, is equal to v prime of t. And so for part A, we would answer because A of t is increasing when, we'll say when in this case since t is time, when v prime of t is greater than 0, the car acceleration is positive on, when we say on, we mean on the interval of, if we look at the graph, we see the slope of this relation showing the velocity is positive between 0, t equals 0, and t equals 35. So 0 to 35. And also this other section here between the cars, the slope is decreasing between 35 and 45, but between 45 and 50, the slope of the velocity relation is on the increase. And so we have the answer and the justification. Okay, now we're going to look at part B. Find the average acceleration of the car in feet per second over the interval 0 to 50. Well, again, since A of t equals v prime of t, we have the average rate of change of velocity equals average acceleration. And for that, rate of change of velocity equals, we take, if we look at input of 35, and we can look at the table, we have an output of 80, actually it's at 50, we have an output of 71, so we have 72, and we have 0, so it'd be like, this would be B at 50 and A at 0, and then we have, what's that, 50 over minus 0. So we can just leave this as 72/50ths, and it says give correct units, average acceleration, and that's going to be feet per second squared. And then if we simplify further, which we don't have to, I think we end up with 1.44 feet per second squared, but we can leave this unsimplified version here as a correct answer. If we simplify and make an incorrectly simplify and get a wrong answer, we can lose the point that we have worked so hard to obtain so far. And then part C, find one approximation for the acceleration of the car in feet per second squared at t equals 40. Show the computations used to arrive at your answer. So for this part C, there are different ways we can do this. One thing, we're looking at 40. So one thing I like to do is take the values surrounding that 40. So if I let B equal 45 and A equals 35, so we're looking at f of B minus f of A over B minus A. And that's going to be, in this case, we have f of B is 60 minus f of A, which is 81, over B minus A. Well, that's going to be simply 45 minus 35, and that's going to be negative 21 over 10, so that's going to be negative 2.1 meters per second squared. Now, one thing you should be aware of is that the AP readers will accept, like I did, the values surrounding the point of evaluation, or the number of evaluation, which is 40. But you could have also got a correct answer by taking 40 and using 40 and 35, or 45 and 40. And so this is an example where there were 3 possibilities for correct answers. Good luck. I hope you're getting the hang of this relationship between position, velocity, and acceleration. Thanks for viewing.